Okay, for our fourth example, and this is very similar to the ones that start off on section 2.2 in the homework. Now you've got two parts happening. So the person is walking this time 1 kilometer at 30 degrees west of north, and then they turn and they walk 2.5 kilometers due south. And we have to find the resulting displacement of the person, so where they ended up. So think about what's kind of happening here. If I have my north, east, south, west. They're walking 1 kilometer at 30 degrees. So let's say that's 1 kilometer, 30 degrees west of north. They've walked 1 kilometer. And then from this location, they're walking 2.5 kilometers south. So they're going 2.5 kilometers south. And what we're trying to find is where are they from where they started. So what is their kind of resultant vector here? And there's different ways that we could work this out. But what I want you to do when you see problems like this with two or more parts is find the resultant, kind of find the XY components for the first section and find the XY components for the second section. And then we're going to find the net kind of resultant from there. Okay, so you split these up into kind of, this was section 1 of the trip, or part 1, this is part 2 of the trip, and we're going to figure out, okay, what are the XYs for each of those. So for instance, for that first one, right, we said he was going north and he was going west. I want to find the Y value of that, I want to find the X value of that for 1 kilometer at 30 degrees. Okay, what are the resultants for each of those? So for my X, right, we said, okay, to find if this is the angle I start with, this is the opposite side, this is the hypotenuse, opposite and hypotenuse is sine. So it's the sine of 30 degrees is equal to X over 1 kilometer. To get X by itself, I'm just multiplying sine of 30 times 1. And since it's going to the west, I'm giving that a negative. So it's negative sine of 30 times 1 kilometer. Okay, whatever that happens to be. And we'll do it in the table in a second. Now the Y value is going up, so it's going to be positive. And this time it's the adjacent side over the hypotenuse. So this one is the cosine of 30 equals the Y over 1 kilometer. So the Y in this case, to get the Y by itself, I'm just multiplying those two. So you can see a kind of a pattern emerging every time we do these problems. It's either sine or cosine of whatever the angle is, multiplied by the hypotenuse. And that's going to keep happening. Now, sometimes people make a mistake and they go, oh, well, the X's are always going to be sine or cosine or whatever. And they're not. We can even see from the earlier problem, the X was the cosine, this one's the sine. So you have to look at the triangle you drew to figure out what's kind of going on with this. Okay, for the second component, he goes 2.5 kilometers due south from that new location. So due south means just straight south. He went 2.5 kilometers. So my X is nothing because he's all in the Y direction. And my Y is negative 2.5 kilometers. So when you get to this section, the 2.2 homework questions, split up the parts of the trip into part 1 and part 2. I like to make a table at this point. So you have kind of how many sections you have, 1, 2, and we'll say our total. And then we have our X, we have our Y. I'll kind of go like this. Hopefully I got enough space. And what we're gonna do is just fill out our table based on what we have here. So for the first one, it's negative sine of 30 times 1 kilometer, which is basically just times 1. So it'll be just, what is the negative sine of 30? And this one is the cosine of 30 times 1 kilometer, positive, right? Because I'm going up. This one's negative because it's going to the left, going west. And then our section 2, we said the x is 0, the y is negative 2.5. And I'm adding my columns, kind of the rows in the columns together. So for this one, I could figure out what negative sine times 30 times 1 kilometer is, or I could just leave it in. For now, I'll kind of show it. I'll show what that calculation is. And then as you get kind of more experience with this, you can just do it all as one step, right? So times 1 is just going to be the negative sine of 30. So that's negative 0.5. So negative 0.5 kilometers. And then for the other one, it's cosine of 30 times 1 is 0.866025 ... kilometers. Okay, and what I'm doing now is I'm adding these things together. So for this kind of net column here, I'm going, what's negative 0.5 plus 0? Well, my total is just negative 0.5 kilometers in the x then. And for my y, it's 0.866025 plus negative 2.5. So I can go plus negative 2.5. Gives me that negative 1.63397456 ... kilometers. 9745, sorry, 96. For my two kind of results. And so this is my total, but I'm not quite done yet because I still have to draw out my final triangle, what I often call that uber triangle. So now that I've got what my totals are, if I've got a bit more space over here, I can go, well, it's negative 0.5 in the x, so that's just 0.5 like this. And then negative 1.6339 means I'm going down quite a bit. 1.63397 kilometers this way. And what I'm trying to find is that resultant, that angle, as well as how long this line is. So I can do a squared plus b squared equals my c squared like we did before, and I can figure out that my longest side is going to be the square roots. So I've got, there we go. Your values can be stored in the TI calculators. So I just wanted to use that without having to retype it all in. So I've got the 1.6339 squared plus 0.5 squared. Take the square root of all of that is 1.71. So 1.71 kilometers. And because it's asking for the displacement, I have to find the angle still. So the angle is that where I started drawing it, so it's from this angle. So it's going to be the tan of opposite 1.6399 over 0.5. I'm kind of running out of room there. But if I type all that in, the second tan of 1.633974596 divided by 0.5 should give me 72.98, 73 degrees. So 73 degrees south of west. There we go. And if we look back at my original picture, I know it was in that southwest quadrant. Okay, and I can make kind of a good, that fits really well with my estimated answer at the beginning.